Hey guys, let's go over D6, solving this quadratic systems. I got y equals 4x plus 1, I equals 3x squared plus 24x plus 50. Alright, what am I going to do first? The first thing I'm going to do is do my substitution. How can I do the substitution? They're both equal to y. Let me show you guys in a different way. I'm just trying to show you guys multiple representations here. If you write this thing over here, you're going to have something that looks like this. 4x plus y, 1 equals y, right? See that? And then you don't technically need the y variable. So you're going to have 4x plus 1 equals all that. Okay. Now we need to set it equal to 0. So we need to basically move everything away. So I'm going to use opposites to go across the equal sign. The inverse math operation to go across the equal sign. Why is that the case? Because it equals 0. 4x minus 4x equals 0. 1 minus 1 equals 0. Then I'm left with 3x squared plus 20x plus 49. Okay. Now at this time you can deploy the discriminant. And what the discriminant tells us is how many solutions there are going to be. B squared minus 4ac, and then you're going to put an inequality in this box. Okay, let's do that together. It's like purple. B is 20. 4, A is 3, and C is 49. I think it's going to be some kind of huge number. So just punch in your calculator. Got my handy dandy calculator right here. 20 squared gives me 400. Okay. Try that again. 400, and then negative 4 times 3 is negative 12 times 49 gives me negative 588. And if you add those together, that's negative 188. So what can I put in this box as an inequality? Negative 188 is less than 0. Okay, why is it important to do the discriminant? Okay, because you would have gone on forever to work on that equation to solve it, and then solve an x and get a y and get an order pairing graph. Okay, it's basically telling us that the graphs won't intersect, and it basically tells you to stop. Now, I know students who are going to be kind of lazy and just say, okay, I could just say that for every single graph. You've got to check the discriminant. All right, let's graph this thing. Let's go ahead and graph the linear first. Super easy. The mx plus b, right? B is the y-intercept of 1. And then a slope of 4. Remember, slope is rise of 4 and a run of 1. What does that mean? Up 4, right 1. Okay, let's do that from the y-intercept. Up 4, 1, 2, 3, 4, right 1. Boom, that's a point. You can do it all day long. Right, 1, 2, 3, 4, right 1. And so we said that was green, so let's go green. Ready? Okay, here's my linear graph. Okay? Alright, let's try a more difficult one now. Let's choose, I don't know, purple. Have I done purple? We're going to make it a purple graph. But to work with this purple graph, you have a standard form in quadratics, no parentheses, right? And here is my y-intercept. Okay, let's think about this, y-intercept of 50, my graph only has, I'm assuming, 10, so it's like way off the page, like way up there, okay? Way higher than the page, and then it goes up, it's an A value, so it's going graphed up. So how do I reconcile this graph, okay? I don't know, I'm just drawing this graph. Oh, it's a purple, right? A lighter purple, okay? I don't know, something like this. Does the graph ever intersect here? Do the purple and the green over here intersect? No. And that's what we said way down here with the discriminant, right? So let's prove that and use our graphing calculator, okay? So let me show you guys the graphing calculator I'm using. I'm using the one here on the right called Graph, G-R-A-F, in Calc 83. I just checked today, it is free. And what it is a, looks like a regular graphing calculator, okay? And let me find it. I forgot what problem we're doing. Okay, so go to y equals in the top left, okay? Use the up and down arrows and you're just going to press the word clear. You can use Desmos too. So 3, and then here's my trick for x squared. It's x. There's actually multiple places where it says x. X on the far right is the math operations in blue, so don't touch that. It's the one to the top left next to alpha. Now there's also an x, I think I see, no I don't, so just use that one. Use it twice, because x times x is x squared, plus 24x plus 50. And I changed it to be green, and if you go down, you can just click on that and change it to whatever color you want. So I just picked a different color that's super obvious. And it's kind of cool because you can see the inequalities of different colors. Alright, I got 4x plus 1. And then you're going to press graph. Now, in a regular calculator, a graphing calculator is in the top right, but this one is in above mode. So you just press graph, okay? And there's my graph. Does that kind of look like ours, right? The intersection of 50 up here, right? That was the y-intercept, and the graphs won't intersect. We saw that based off of the discriminant, okay? See you guys.